Hi class, today we're going to be talking about page 1 on section 6.1, operations on functions. So our standardized test practice problem reads, what value of k would give us a remainder of 6 when x squared plus kx plus 18 is divided by -4? So what we're going to do is we're going to use synthetic substitution. We're going to put a -4 in where x is, and we're going to set this equal to 6 because it says that's what our remainder is. So what we'll have will be -4 squared. I'm sorry, my pen is not working quite right. Let me restart that. We'll have -4 squared minus 4k plus 18 equals 6. We'll have 16 minus 4k plus 18 equals 6. So let's add 16 and 18, that would be 34. So we'll have -4k plus 34 equals 6. We'll subtract 34 from both sides. And that's going to give us -4k equals -28. Divide by -4 on both sides, and that will tell us that our answer is A. K is equal to 7. Okay, so we're going to define what the operations of functions look like. If it is a sum of two functions, then you just simply take the functions f of x and g of x and add them together. If it's the difference of functions, you would take f of x minus g of x. If it's the product of functions, we'll take f of x times g of x. And if it's the quotient of functions, we'll take f of x over g of x. So we'll simplify with using the first three, the sum, the difference, and the product. But with the quotient, we'll just write it out. We won't simplify with it. Okay, so we're going to start with finding the sum, the difference, the product, and the quotient of f of x and g of x. So for the sum, I'm going to write down f of x, x squared plus 3x minus 4, and I'm going to add to that the g of x. So I'm going to just combine my like terms. 3x and 3x will be 6x, and -4 minus 2 will be -6. Now if I take the difference of the two functions, what's going to happen is this is going to become a -3x, and this is going to become a +2. So I'll have x squared plus 3x minus 4 minus 3x plus 2. So that the 3x's will cancel, and we'll have x squared minus 2. Now when we multiply, since g of x is shorter, has fewer terms, we're gonna use the distributive property, but I'm gonna take the g of x and I'm going to stack it. So I'm going to write it as 3x minus 2. And out beside both of these, I'm going to put in parentheses f of x, which is x squared plus 3x minus 4. Okay, and so I don't run into this one. I'm going to distribute, and I'm going to write my answer down here. So I'm going to have 3x to the third, and then I'm going to have plus 9x squared, and then I'm going to multiply again. I'm going to have minus 12x, and I'm going to go down to the second line, and I'm going to have negative 2x squared. Notice I line it up underneath the 9x squared. Negative 6x goes underneath the minus 12x, and plus 8. So I will have 3x cubed plus 7x squared minus 18x plus 8. And that will be my answer for the product of the functions. And then the quotient of the functions, just simply write in the numerator x squared plus 3x minus 4. In the denominator, write 3x minus 2. And that's how the quotient of the functions would look. Now for the fun stuff. The composition of functions. So this may be a little tricky to start with, but I'll go slow and explain along the way as needed. The composition of functions reads, suppose f and g are functions such that the range of g is a subset of the domain of f. Then the composite function f of g can be described by the equation f, that's not fog, it's f of g of x is equal to, and this is how you write it, you put f and then your input is your g of x. So the way we're going to look at this is with the following example. We have these ordered pairs for f and these ordered pairs for g. And it says to find f of g of x and then g of f of x if they exist. So what you do is you take, it says f of g of 1. So we go to g and we find when g is 1, for our x, our input, the output is 3. So we put that value of 3 right here. Then we look at f of 3 and see that it is equal to 3. So let's try another one. F of g of 2. So we're taking g of 2, the input, which is the x value, gives us the output, which is the y value. So we put a 2 in here. Now our input is 2. Our output would be 4. So again, x is the input, y is the output. F of g of 3. Go to g of 3 and you see that the output is 4. Now we go to f of 4 and we see that the output is 1. Then we take f of g of 4. We can see that g of 4 is 1. So we take f of 1 and we see that it is 2. So the way our input and outputs now look would be in the following ordered pairs. When we inputted G of 1, our output was 3. So we have the ordered pair 1, 3. When we inputted a 2, our output was a 4. So we have a 2, 4. When we input a 3, we have an output of 1. So 3, 1. And when we input a 4, we have an output of 2. So 4, 2. Now we're going to go the other way. We're going to do G of f of x. So G of f of 1. We look over here, when x is 1, the output is 2. Now we look for G of 2, and we see when G of 2 is 2. Now we'll try G of f of 2. So we go over here, f of 2, we see our output is 4. Now go to G of 4, and we see our output is 1. G of f of 3, f of 3 is 3. G of 3 is 4. G of f of 4. F of 4 is 1. G of 1 is 3. So what we have would be 1, 2. So 1, 2, 2, 1, 2, 1, 3, 4. So 3, 4, and then 4, 3. 4, 3. Okay, that takes care of page 1. We'll do more with functions, composition of functions on page 2, and that will be in our next video. Until then, I hope you have a great day.